As indicated in preceding lectures, in early 1978, I was at the Department of Mathematics of Harvard University under support from the Department of Energy. I have reproduced again this slide to emphasize the point that this time I will be presenting the real research which I did at the Department of Mathematics, which is that for Lie admissible formulation for irreversible system. In preceding lecture, I presented the particular simpler case of Lie isotopic formulations. In this way, following a 10-year lapse of time without any appreciable research on irreversibility, I was forced to resume research in the field because essential for my research program with the Department of Energy. During my PhD studies, I had indeed identified the foundation of a possible representation of irreversibility that at least was sufficient for my continuing the research. And the essential results of the PhD thesis, let's recall them, was that, first of all, the identification and the representation of irreversibility with the infinite family of external terms in Lagrange and Hamilton's equation, external terms in Lagrange and Hamilton's equation. I also learned that an effective algebraic way of representing irreversibility was generalized the Lie algebra into a Lie admissible algebra, and that the possible additional presence of a Jordan algebra, then it will allow a direct representation of irreversibility from an algebraic viewpoint. Despite those advances, I had essentially produced a very primitive and rudimentary model given by the parametric generalization of the Lie product that we indicated before. Now the task was rather serious, because to achieve any meaningful advance in the representation of nuclear fusion, I had to achieve a representation of all infinitely possible, regular and non-singular, external terms of the analytic equation at both classical and operator level. So I resumed my research by first considering the time evolution of an observable A characterized by the true Hamilton's equation, those with external terms, the external term being represented here. I immediately discovered that this equation characterized a triple, what is algebraically called a triple system, and not a bilinear bracket. As a result of which the triple system violates the right scalar and associative axiom and cannot possibly characterize an algebra as commonly understood in mathematics. Now, the lack of an algebra in the bracket of the time evolution was a major insufficiency. Essentially, will cause me a paralysis in really doing further significant advances for a number of technical reasons. So my task was clear. I had to reach a reformulation, identical reformulation of Hamilton's equation with external term in such a way that it will characterize a bilinear bracket in the time evolution rather than a triple system. And after a number of trial and error, finally I had this simple idea of introducing this function, careful that in general is a matrix, but in this case, one-dimensional case is indeed is a function given by 1 minus the infinite family of external forces, F, divided by the partial derivative of the Hamiltonian with respect to the linear momentum. And I inserted this expression here in between the two partial derivative of the second term of this time evolution. And by reaching in this way an identical reformulation of Hamilton's equation with external term, however, in such a way that it will characterize an algebra because it is bilinear. In particular, this algebra clearly had to be Lie admissible as needed, and therefore I was happy about this result. I published this algebraic reformulation of Hamilton's time evolution with external terms in a paper of Harvard University dated 1978. And then I wrote 2 volumes entitled Lie Admissible Approach to the Hadronic Structure, that were published a few years later, to illustrate how a basic idea, when truly fundamental, may have a truly incredible number of subsequent development. And in fact, in these 2 volumes of the admissible approach to the hadronic structure, I introduced, for instance, an irreversible lifting or completion, if you want, of the Minkowski space-time called Gano-Minkowski space-time. I introduced an irreversible completion of the symplectic geometry, and a number of other models that represents the irreversibility in the ultimate structure of the formulations. I should indicate why the title Lie Admissible Approach to the Hadronic Structure. This was talking about 78 to 79, when everybody was using Lie algebra for the representation of hadrons. And the reason for going from Lie algebra, such as SU3 that was used at that time, to a Lie admissible algebra, was that all hadrons are highly unstable, with the exception of the proton. Consequently, from an axiomatic viewpoint, that representation via Lie algebra essentially eliminated the very essence of the structure, namely that they are born and they decay very, very fast, by therefore being strictly irreversible over time. And in my view, a Lie admissible approach was necessary for axiomatic consistency. I still have the same view, and that's the reason why I work on at the level of Lie admissible theory, and then extract very quickly Lie isotopic particularizations. Following the achievement of a universal Lie admissible representation of analytic equations with all possible external terms, I had to pass the very heart of my research program, namely a representation of the external terms at the operator level. The task was rather difficult because of a number of requirements. First of all, I had to achieve a method capable of representing all at the operator level, all infinitely possible external terms that exist at the classical level, because they are the origin of irreversibility, in my view, as well as the view of Lagrange, Hamilton, Jacobi, and several other founders of analytic mechanics. After that, I had to achieve a compatibility with the classical formulation. This was at the time in which there was no operator map of classical Lie admissible method into a corresponding operator form. But then there were a number of other requirements. For instance, let's recall from lecture 1 that isomathematics has permitted the achievement of a crucial property, namely the prediction of the same numerical value under the same condition, but at different time. A condition which is essential for consistent experimental verification. Well, my task was to achieve exactly the same result, namely predict the same number under the same condition at different time, but this time under all possible irreversible conditions represented by Lagrange and Hamilton external terms. So I went to work, and what I did, I re-examined the ultimate foundation of reversibility in quantum mechanics. And in my view, it originates from the fact that the product using quantum mechanics, all level, from number to integral differential operators, this product does not require any ordering, because the product of the number 2 multiplied by 3 to the right yields exactly the same result as the product of the number 3 multiplying 2 to the left. Then I immediately saw that under isotopy we have exactly the same feature, because it is true that in between 2 and 3 now we have the isotopic element which is sandwiched there. But nevertheless, so we have two actually product. But nevertheless, this isotopic product of 2 multiplied by 3 to the right give exactly the same result as 3 multiplied to iso multiplied 2 to the left, because the isotopic element is Hermitian and non-null. So therefore, then I had the idea that one way to represent irreversibility with the ultimate and most powerful and most significant axiomatic structure is by introducing an ordering of the product, namely by differentiating the product to the right from the product to the left. A theory that becomes, in this way, a non-trivial bimodular formulation. And I introduce in this way a unit that is called genotopic element S for the ordered product to the right. And then I introduce a different quantity, non-null, but different than S, I call it R, for the ordered product to the left. And I recognize immediately that an axiomatic representation of irreversibility will follow on the simple assumption that, that R and S are non-null and not equal to each other. In this way, I reach the following basic assumption for the operator representation of irreversible processes for in physics, chemistry, and biology, according to which motion forward in time require the sole use of all products being ordered to the right, and in addition to be genoproduct, namely to have a quantity called S sandwich in between the two terms of the product, which is called the genotopic element. Consequently, motion backward in time should be solely represented with the ordered genoproduct to the left, with no exception. And the new quantity R, operator, function, or number is called the genotopic element to the left. Representation of irreversibility at the axiomatic level is then guaranteed by the two genotopic elements R and S being different among each other. I published this basic assumption in this paper released by Harvard University in 1979, and then developed thereafter, as we will see in subsequent slides. Notice that the above assumption allows the preservation of all good features of the isotopic theory, namely S is the same characteristics of the isotopic element, therefore it can represent the actual dimension, shape, and density of particles, but in addition contains additional elements representing irreversibility over time. I wrote a systematic presentation of the above ideas in my 2 volumes of Foundation of Theoretical Mechanics, and with particular reference to the second volume, page 129, equation 19, that presented the central equation of hadronic mechanics, which is applicable to physical, chemical, and biological system. It is written here, up here. As we can see in this first term, consists of a multiplication of Hamiltonian to the left toward the observable A, while the second term represents the multiplication of the Hamiltonian to the right. Therefore, I introduced those 2 symbols to represent the genoproduct to the left and the genoproduct to the right. And then it is very easy to see that this product is indeed Lie admissible, because it can be decomposed into this first totally antisymmetric terms plus a totally symmetric one. The totally antisymmetric one verifies the axiom of Lie algebra, but it is realized in an isotopic form, so therefore is most technically known as Lie-Santilli isoalgebra, while the product, the totally symmetric product, does indeed verify the axiom of Jordan algebra, but it is isotopically mapped, and it is known as Jordan-Santilli isoalgebra. In practical realization, we assume that that the genotopic element to the left is number 1, and the genotopic element to the right is 1 minus this infinite family of external forces representing irreversibility divided by the Hamiltonian. It is then very easy to see that this general Lie admissible time evolution known as Heisenberg-Santilli Geno equation indeed acquires this explicit form, which most importantly, the last term is essentially the same as occurring at in the classical true equation by Lagrange and Hamilton, namely is the product of the observable multiplied by the external terms. In this way, I achieved universality in the representation of all possible external terms existing in Lagrange and Hamilton's equations. I published these results in this paper, memoir actually printed dal Nuovo Cimento of 2006, with a considerable number of practical applications that I recommend to interested colleagues to inspect. And most importantly, I show that those equations are directly universal for all possible non-conservative systems while having a consistent algebra in their structure. Additionally, in this paper, I emphasize the historical important role of Jordan, not only Lie, but also Jordan algebras in the achievement and the representation of irreversibility. It is important to verify the preceding algebraic derivation from a group theoretical viewpoint. This will give also the opportunity of seeing the sequence of completions which have been studied in honor of Einstein, Podolsky, and Rosen. Let's begin by reviewing the group structure of the time evolution law of quantum mechanics, which is given here. It is a transformation group consisting of an action from the left on the observable A and an action from the right, which is the finite group theoretical version. The infinitesimal form is the conventional, well-known Heisenberg equations that we use in practical applications. The Lie-Santilli isotopy essentially preserve the indicated quantum mechanical structure. The only difference being that we have an isoproduct from the left and an isoproduct from the right on the observable, resulting in this isogroup structure. Its infinitesimal form is Heisenberg-Santilli iso equations that we have indicated a number of times. The next completion is the Lie admissible group structure, which is represented here in this line, which again consists of an action from the left and an action from the right, therefore having a bimodular structure. But the two modular actions are inequivalent by central assumption. So therefore, we have here the finite version, and its infinitesimal form is precisely the equations that we have presented before. Those preceding two levels, quantum mechanical, isotopic, and genotopic levels are recommendable for a number of physical applications, but definitely not for biological structure due to the complexity of life in the universe. Indeed, there has been a next level of completion, which is called by Wojciechowski's hyperstructural formulation of the time of irreversibility, which I will briefly touch in the next slide. And even then there is an additional one for antimatter, which is not treated in this teleconference. It is important to complete the preceding algebraic and group theoretical Lie admissible representation of irreversibility via the compatible genotopy of all methods that we have learned for the elaboration of data in quantum mechanics. I've stated a number of times that there cannot be a really new physical theory without really new mathematics, and that it cannot be a really new mathematics without really new numbers. Well, it appears that this prediction applies indeed for the representation of irreversibility. In fact, we have essentially two different theories, one for motion forward in time with the product ordered to the right, and then motion backward in time with product ordered to the left. And this implies that each of those two formulations has its own new numeric fields, which I have called Gano fields to the right and Gano fields to the left. They are characterized by the Gano unit, which is to the right, which is the inverse of the genotopic elements to the right, and vice versa. And then by Gano numbers that are the product ordinary number multiplied by the Gano unit, so that not only the size, not only Gano number represents extended object, but also they represent an object with a direction of time. It should be indicated that Gano fields do indeed verify the axiom of a field, because the said axiom simply require an associative product, and without any specification as to whether this product has to be both to the right and to the left. And indeed, by restricting the product to the right, a given field indeed continues to verify the axioms of a field. The next level is the systematic study of the Gano-functional Gano analysis. It showed the Gano exponential, which is the same as the iso exponential, but there is now a direction of time. And finally, and most importantly, is the genotopic completion of the Newton-Leibniz differential calculus. Remember that we have the iso differential calculus for the transition from the characterization of points in Dawn, which is excellent for quantum mechanics, to a characterization of extended particle, which is necessary to bypass the Bell's inequality. Now, in addition to continue the representation of the extended character of particles and their density, we have to add in the differential calculus the direction of time. And that is the essence of the Gano differential calculus. I continue to attract the attention on the fact that an ordinary differential is lifted under irreversibility into this form, which when is projected in an ordinary space implies contains the conventional differential plus an extra term, which again represents the extended character of particle, their density, and in addition, their direction of time. All these methods can be studied in my 3 volumes of Elements of Hadronic Mechanics. And in the event there is any question, authors should be free to contact me. In this slide, I summarize the most important aspect of the Lie admissible representation of the irreversible process at the classical and operator level. I publish those aspects in a paper at Rendiconti, Circolo Matematico Palermo of 1996, which journal is a journal in pure and applied mathematics. I consider this paper the most important paper I have written in my life, because in this paper, I identified for the first time the Gano differential calculus by presenting as a particular case the isodifferential calculus of lecture 1. The most important equation that I have achieved in my life is this one, and it is an irreversible generalization or completion of Newton's equation of motion in such a way that to allow the abandonment of the 4 centuries old notion of massive point, because planets, ladies and gentlemen, are not massive point, they are extended in nature. And I believe the extended character has indeed an influence on the Kepler law, although perhaps too small to have appeared in study to date. But in addition to the extended character, this equation allows the representation of masses also with a direction in time, because masses of planets are not constant in time due to continuous absorption of gases while during their travel in interplanetary spaces. Then next, the Gano differential part here is crucial because it represents the non-conservative forces, which are technically are characterized as variationally non-self-adjoint, while the other four forces are variational self-adjoint, namely they are conventional forces derivable from a potential, so can be explicitly written. Another important implications of the Gano differential calculus is that all infinitely possible regular and non-singular Newton-Santilli Gano equations can be uniquely and unambiguously represented with a new variational principle, which is introduced here as a forward Gano variational principle. The significance of this principle is that of having allowed, apparently for the first time to my knowledge, the application of the optimal control theory to actual volume and surfaces of physical reality, such as study the optimization of a wing while it is within a physical medium, therefore experiencing a non-conservative resistive forces, which feature do not allow any use of the optimal control theory for ordinary mathematics. It is also important to have an idea of explicit expression of the genotopic element, or if you want, the Gano unit as its inverse, that we use in industrial, let alone scientific applications. Here is indicated with the letter T with an up and arrow, which is equal to the quantity of the genotopic element S of the preceding slide. It is given by the diagonal present also in the isotopic theory. The first three terms representing size, shape, homogeneity, anisotropy and the physical actual planet, in this case at the classical level, and the fourth element representing density. The most important part for the representation of irreversibility is this exponent, which is also present in isotopic theory. However, this term in isotopic theory is invariant on the time reversal. And while here it is at the genotopic level or the admissible level for the representation of irreversibility, this exponent has to be crucially dependent on time in such a way not to be invariant under time inversion. What is very important for our apparent verifications of the EPR argument is this minus sign, because the quantity gamma function here at the classical level, operator at the operator level, it is always positive, definitely. So therefore, the genotopic errors are always not only smaller than 1, but much smaller than 1. And this is a crucial feature. If one looks at the proof of the theorem, this is a crucial feature that apparently allows the realization of Einstein determinism also under irreversibility, as it is expected to be. The last two lines are essentially a rather simple genotopic map of all the corresponding operations in quantum mechanics. First, to do any practical applications, we need the explicit expression of the linear momentum in a form compatible with Lie admissible theory, and it is allowed only by the Gano differential calculus. Otherwise, there are a number of incredible inconsistencies that interested colleagues should really touch with their mind to see them, so that you can see the fundamental character of Gano differential calculus. Once the Gano linear momentum is known, then it's very easy to subject to a genotopic map the conventional naive quantization, therefore resulting in this equation, which is today known as the forward Newton-Santilli Gano equations. Notice again at the end, there is a Gano eigenvalue with the up and arrow, but there is a genotopic product here. So after canceling the unit, you end up with an ordinary number E multiplied by the wave function. However, keep in mind that unlike it is the case with quantum mechanics, this Schreidinger-Santilli Gano equation by conception represents non-conservation in over time, because essential for the representation of irreversibility at the operator level. The criticism that I often heard on, in regards to the Lee admissible treatment of irreversibility is that the formalism is too fancy. Well, let me go back in time in the early part of the past century, and I'm sure some of you know the historical account according to which Newtonian physicists will consider fancy the formalism given by Hilbert spaces and all that. Well, eventually those physicists had to admit the necessity of using the new formalism of quantum mechanics because necessary for a representation of the experimental data in atomic structure. It may well be that a similar situation will eventually result to be necessary for the representation of irreversibility because basically new physical and chemical and biological events are expected to require basically new mathematics for a serious quantitative treatment. Independently from that, it should be stressed that the mapping of any given model of quantum mechanics, including a model for nuclear fusion, can be easily transformed from their Lie structure to their covering Lie admissible form, including the representation of irreversibility, via a method so simple that can be easily implemented by first-year graduate students. This method essentially requires two non-unitary transforms, U and W, and then identifying the forward Gano unit according to this expression as the product of the non-unitary transform U multiplied by the Hermitian conjugate of W. Then once this identification is done, then each and every part of a quantum mechanical model can be uniquely and unambiguously mapped into a Lie admissible form. For instance, numbers will become Gano numbers. Conventional unit will become a Gano unit. Conventional associative product of quantum mechanics will become a Gano product, etc. In a way that is truly elementary and should be actually done by physicists to see their simplicity. We now remain with the final equally important aspect of verifying that indeed the Lie admissible representation of irreversibility do indeed predict the same number under the same condition, but at different time. I studied this problem and proposed a resolution in this paper of 1997 at Foundation of Physics. And it is a very simple enlargement of the method already presented in lecture 1 regarding the case of isomathematics. Indeed, it is based on this unique and unambiguous reformulation of any given pair of non-unitary transform into such form which is called Gano unitary. After this simple reformulation, it's very easy to prove that the Gano unit is invariant under Gano unitary transform. I repeat, Gano unit emerge as being numerically invariant under the infinite class of Gano unitary transform, by therefore confirming the preservation over time of dimension, shape, and density and direction of time, of course, provided that the formalism which is applied is compatible with the basic axiom of the theory.